Let us solve this question. 15th, cot 4x times sin 5x plus sin 3x. This is what you have in the LHS. In the RHS, you have another complicated expression, cot x times sin 5x minus sin 3x. This is what you have in the RHS. Can you please observe that both LHS and RHS have complicated expressions. Okay. So the general method of proving that we follow is you start with the LHS and try to simplify it into the RHS. RHS is generally a simplified expression. Okay. But here both LHS and RHS are complicated. So in that case, what can be done? One of the approaches that we can follow is, okay, so let's start from this complicated expression, simplify it and try to convert it into this form. Now, that will be difficult, right? Another approach of proving is you simplify the LHS into something, you simplify the RHS into something and they become equal. That's a simple way of proving. You are converting this into some form, you are converting this into some form, and if they both are equal, then obviously the LHS will be equal to the RHS. Yes, that's a simple approach which will work over here. Another idea which could have been used in this question is, first you remodel the question. Okay, first you remodel the question and then you solve. Okay, a remodeling would work over here. Yes, a remodeling would be very beneficial over here. Let's take a look at that method 1 over here. Method 1. Okay, now some people may not love this method, but some teachers of your school may not love this method, but that does not make a difference. This method is perfectly okay, keeping in mind certain restrictions, right? Keeping in mind certain restrictions. So let's take a look at method 1. What I have is given cot 4x times sin 5x plus sin 3x is equal to what? Is equal to, you have cot x outside and you have sin 5x minus sin 3x on the inside. Cot x, and in the bracket you have sin 5x minus sin 3x. Okay, I want to remodel this. Okay, how do you want to remodel this? What I want to do is, I want to bring the complicated terms together and the non-complicated terms together. What I'll do is sin 5x plus sin 3x, let's divide by this term over here. Let this remain over here and divide by that bracket on both sides. What about this cot 4x? We'll take it on the right hand side. This is in product, we'll take it on the right hand side. This is sin 5x minus sin 3x, okay, which is equal to, can you observe there's a cot x in the numerator and you will get a cot 4x in the denominator. This is what you get, right? And now I'll try to prove this one first. So proof, let's take a look at the proof of this one. Now the LHS at this stage is complicated, whereas the RHS is simplified, right? So this becomes a general proof, regular thing, and we can handle this. This is sin 5x in the numerator, and in the denominator you have sin 5x minus sin 3x. Okay. How do we simplify this? In the numerator you have something looking similar to sin C plus sin D, right? So what is the identity for sin C plus sin D? This is a familiar identity, right? Sin C plus sin D is 2 sin C plus D by 2 cos C minus D by 2. This is what you have. What about the denominator? In the denominator I have something which looks like sin C minus sin D. Okay, and sin C minus sin D is also a familiar identity, very important one. This difference can be converted into product. What is this equal to? This is 2 cos C plus D by 2 sin C minus D by 2. We can use these two identities to simplify this expression. How do we do that? In the numerator, you observe this is sin 5x plus sin 3x, which is similar to sin C plus sin D. Sin C plus sin D is 2 sin C plus D by 2 cos C minus D by 2. So instead of C, you have a 5x over here. Instead of a D, you have a 3x over here. Okay. and they can be converted in that form. This will convert to 2 sine 5x plus 3x by 2, okay, which will be sine 8x by 2. This will 2 sine 5x plus 3x 8x by 2 and cos of 5x minus 3x by 2, right, sine c minus d by 2. Cos of, what is 5x minus 3x? That is 2x by 2. In the numerator you get this. What about the denominator? In the denominator you have sine 5x minus sine 3x, which is equivalent to sine c minus sine d. That will be equal to 2 cos c plus d by 2 sine c minus d by 2. This is 2 cos 5x plus 3x by 2. 2 cos, what is 5x plus 3x? That is 8x by 2. Sine 5x minus 3x by 2. Clearly observe that this is 2x by 2, right? Can we simplify this further? Yes. Let's simplify this further. Therefore, LHS is equal to what? Let's take a look at the LHS. You have 2 sine 4x sine cos x. 2 sine 4x cos x in the numerator. What about the denominator? Do you observe? You have 2 cos 8x by 2, which is 4x, sine 2x by 2, which is sine x. This is what you have in the denominator. And let's cancel these factors of 2 sine 4x upon cos 4x. This will be equal to, in the numerator you have sine x, sine 4x over cos 4x. In the numerator it can be converted into tan 4x, or if you require, if you want to write it in terms of cot 4x, let's write cos upon sine. In the denominator you have cot 4x. Okay. What about this? This is cos x upon sine x. In the numerator you have cos x, and is this equal to the RHS? Yes. And this is what you wanted to prove. So this is complete proof using this method 1. A slightly remodeled question. But then if you want to use, if you want to solve this directly using this. So what we'll do is we'll simplify the LHS first and we'll simplify the RHS in bit, and let's see where does that take us. So method 2 looks something like this. We are talking about method 2 over here of handling this question. Let's simplify the LHS. LHS. Yes, what does the LHS look like? LHS has a cot 4x and these terms over here. Sine 5x plus sine 3x. Now this cot 4x, you cannot do anything with this cot 4x. This will remain as it is. At max we can write it as cos 4x upon sine 4x for now. Okay. What about the sine 5x plus sine 3x? This can be simplified using an identity of converting sum or difference into product. We know that identity. Let's use that identity. Since sine c plus sine d. This looks like sine c plus sine d. Yes. Sine c plus sine d is equal to 2 sine c plus d by 2 cos c minus d by 2. Let's use that. Yes. This is the identity. So which gives me LHS will be equal to what? The cot 4x will remain as it is. Yes. What about this? This is sine 5x plus sine 3x, which is similar to sine c plus sine d. This will convert to 2 times sine of c plus d by 2, sine 5x plus 3x by 2, that is sine 8x by 2. Cos of 5x minus 3x by 2, which is cos of 2x by 2. Okay, this is what I get, the bracket. Now all of these terms are in multiplication. Can you observe that? Yes. This term in the middle will be converted to sine 4x. This is cos x, which is pretty simple. Okay. And what else? This cot 4x can be written as cos 4x upon sine 4x now. This will be cos 4x over sine 4x. And the other terms are simple. The other terms are sine 4x and cos x. Can you observe that the sine 4x will get cancelled from here and here, and what you will be left with is 2 cos 4x times cos x. This is the simplified version of LHS. Now what about the simplified version of RHS? Can we also simplify the RHS in a similar manner? Yes, we can simplify the RHS. Let's write the RHS first. In the RHS, you have a cot x outside and you have sin 5x minus sin 3x in the bracket. Okay. Now cot x at max we can write it as cos x upon sin x, but that's not required now. What is more useful is to simplify this sin 5x minus sin 3x. Now how do we simplify sin 5x minus sin 3x? That can be simplified using transformation identities, transformation of difference of two signs in terms of product. Okay, how do we do that? There's the result, sin c minus sin d is equal to, let's see, since sin c minus sin d is equal to, we have a result similar to this, right? Sin c minus sin d is equal to 2 cos c plus d by 2 sin c minus d by 2, similar to this. It's 2 cos a very useful result. A very useful result, yes. You should remember this result by heart. And let's use this result now. In the LHS you have, in the RHS you have cot x. Let cot x remain as it is. What is there in the bracket? Let's take a look at this bracket. This is sin 5x minus sin 3x, which looks like this. It can be written as 2 sin 5x plus 3x by 2, which is 2 sin 5x plus 3x by 2 is actually 8x by 2 in the bracket. The second term is cos of 5x minus 3x by 2. That would be cos of 2x by 2. Right, that's what you have. Now, this cot x can be written as, what can this cot x be written as? This can be written as cos x over sin x. What else do you have in the bracket? You have 2 times sin 8x by 2, which is actually sin 4x. Cos 2x by 2, which is cos x. So this is sin 4x. This is cos x. Just a minute. Did we make any mistake? Yes. This was actually cos over here, right? Okay, let's not make that mistake. This was a cos over here. This was a sin over here. Let's keep that in mind. This was a cos over here. This was sin over here. This is cos of 4x and this is sin of x. Yeah. Now you can observe that these sin x are getting cancelled and what remains is 2 cos 4x times cos x. Now if this is statement 1, if this here is statement 1 and this here is statement 2, so using 1 and 2 you can observe that LHS is equal to the RHS. Using 1 and 2 we can say 1 and 2 combined imply that LHS is equal to RHS, and that's the complete proof for this question over here using this method, as you can clearly observe. Is it all? Yes, that's all in this question.